Hello everybody. Today we're going to learn about multiplying powers with the same base. It's a pretty simple concept. When you have a number raised to a power times that same number raised to a power, you just add the powers together. So for instance, x to the third times x to the fourth is just x to the 3 plus 4, which is x to the seventh. It's easily provable by just writing out the exponential form into expanded form. So x to the third just means x times x times x. And then x to the fourth, actually I'm going to get rid of those parentheses. So x times x times x, so that's the x to the third, times x to the fourth. So writing it out in expanded form shows you pretty simply that this is x to the seventh. Okay, but this rule will make it easier. Now if you forget the rule, then by all means you should write it out in expanded form so that you get your answer. So I'll do it again in here. We have 3 squared times 3 to the third. Should be 3 to the 2 plus 3, which is 3 to the fifth. And then you would be expected to actually write out what 3 to the fifth is. It's, what is that, 3 times 3 times 3. I think that's 81 times 3, so 243. Alright, so one of the instructions in the classwork for tomorrow will say rewrite each expression using each base only once. It's basically their way of saying, show that you know the rule and write 4 to the ninth, but they're not going to make you figure out what 4 to the ninth is, because you would really want a calculator for that, or else it would take a long time to do on paper. Now down here, when you get something like -6 to the third times -6 to the seventh, keeping in mind also that the base is the same, so we have -6, and we're just going to add the exponents. So 3 plus -7 is going to equal, that's kind of a bad equal sign there, is going to equal, whoa, what did I do? -7. So it's going to equal -6 times, or to the -4th power. Now, if you remember from last video, you can't have a simplified answer with a negative power, so you would want to write 1 over -6 to the fourth. And then again, if the instructions were different, you would actually multiply out -6 to the fourth power. Alright, moving on. So now we're going to multiply powers in algebraic expressions. So now we have some coefficients here, the 8 and the 5, and let's see how that works. Keep in mind this is all multiplication again, and just as we can write 2 times 3 times 4 equals, I don't know, it's 24, and you can also switch around the order, 3 times 2 times 4 still is going to equal 24. So it's important to remember that you can switch around the order here, and so that's what I'm going to do in this case. Being that everything's being multiplied together, I'm going to put the coefficients out here in front. I'll deal with those separately, and then I can deal with the variables separately as well. So here we have 8 times 5, which is 40, and then we're going to add the powers together. So 5 plus -11 is -6. Okay, so I'm essentially splitting everything apart and then smushing it back together for the final answer, which is right here, 40 x to the -6th. Alright, so for the next example here, we have 3 different things being multiplied together. Again, it's all multiplication. 4 next to y is the same as this multiplication sign here. So I'm going to split the numbers out, and then I'm going to split the variables out. So 4 times 3 is 12, times 6 is, what, 72? And then y by itself, keep in mind that when there's no exponent there, it's not a 0, but there's a 1 there. Anything without a power is always considered being to the first power. So keep that in mind. So when we add up these powers, we have 1 plus 3 plus 5, which is 9. So 72y to the ninth. Done. All right, let's get something that doesn't come up very often, but it's scientific notation. There are times that come up when you need to multiply scientific notation. When that happens, keep in mind it's all multiplication. So again, you can split the these front numbers out. So we could say 2.5 times 4, and then we can deal with the powers of 10. So 10 to the negative fifth times 10 to the eighth is just 10 to the negative 5 plus 8, right? So now 2.5 times 4 is 10, and then this is 10 to the third, right? So now we actually have 10 times 10 to the third power, which is what, 10 to the fourth power? Okay, it's not always going to come out where these numbers here multiply to become 10. So let's say they didn't multiply to become 10. Let's say they were like 3.5 or something times 10 to the third. Keep in mind we were dealing with scientific notation, so we could leave it as scientific notation, right? Or if it's small enough, you could actually write it out. What was that, 35,001? 2, 3. Nope, I put an extra 0 on there. Oh, that was big. 3500, right? 1, 2, 3. Okay. So let's move on. Here's something that you haven't seen before. You've seen square roots before, but you haven't seen them as powers. So we all know that the square root of 9 is 3. And we all know that the square root of 25 is 5. There's also something called cube root, which I don't know if you've seen before. But similar to square root, where it's like what number times itself would equal 9. For cube root, it's what number to the third power would equal 8. And so it's 2, right? 2 times 2 times 2 is 8. So the cube root of 8 is 2. And the cube root of 27 is 3, because 3 times 3 times 3 equals 27. Well, algebraically, the way we show it is with powers. So square root of 9, actually I put it on this side, is actually 9 to the 1/2 power. Square root of 25 is the same as writing 25 to the 1/2 power. So basically what you're saying is what number times itself would equal 25, and so it's 5. Let me slide this one over a little bit, and I'll slide this one over. So with the cube root, you might guess here that it's 8 to the 1/3 power, and over here it would be 27 to the 1/3 power. Okay, so 8 to the 1/3 power just means cube root of 8, which means 2, and so on. So let's use this in a couple examples. So here we have 16 to the 1/4 power, which means what number multiplied by itself 4 times would equal 16. Now it seems harder than it is, because how many numbers get large so quickly that there's only a couple choices you could have here. If you start with, obviously it's not 1, because 1 times 1 times 1 times 1 is 1. So then you go to the next number. 2 times 2 times 2 times 2 is 16. So it looks harder than it really is. It's actually pretty simple. Now when you get to this might be a little more confusing. But if you split it up, kind of the reverse of what we did at the beginning of the lesson, we know that we have 9 to the 1/2 power times 9 to the 1/2 power times 9 to the 1/2 power. Remember, in the beginning of the lesson, we would have said, well, these all have the same base, so you just add the exponents. So 1/2 plus 1/2 plus 1/2 is 3/2. In this case, we could split it up. So we actually know that the square root of 9, or 9 to the 1/2 power, is 3. So these are just all 3's. So it's actually 27. Okay. Another way to think about this is kind of deal with the, I guess it's the same way as that, but I kind of do it in my head. I think, okay, well, first of all, I need to find the square root of 9. So I look at the bottom number first, which is 3, and then I need to cube it, right? So this is like saying 3 to the third power, 27. Okay, and let's try one more example. Here we have something that looks like a crazy mess, but it's actually going to be quite a simple problem. Remember, it's all multiplication, so we can put things in whatever order we want, and we can organize them in whatever way we want. This goes back to the old associative and commutative properties, but I'm just going to take all the coefficients and move them over here, and then I'll take all the x terms and deal with those. And then I'll take all the y terms and deal with those. And then once I get all that dealt with, I'll smush them all back together and we'll be done. So 2 times 3 times 5, that's easy, that's 30. Okay, now we have the same base here, so we're just going to add the exponents. 2/3 plus 1/3 is 1. So that's just x, right? X to the first power is x. And over here we have 1/4 plus 1/2. Well, 1/4 plus 1/2 is 1/4 plus 2/4, so that's just 3/4. So y to the 3/4 power, and we're done. So basically we just split them apart and grouped similar things together. So coefficients, then x terms, and then y terms, and then actually they're not terms, they're factors, and then smushed them all back together. So that is it for this video. Thanks for watching.